Very good evening, my dear students. Today, we are going to do one more theorem on Cayley-Hamilton theorem. Example number 2. If matrix A equal to 5 minus 2, 3, 1, then find the characteristic equation, find the characteristic roots, and verify the Cayley-Hamilton theorem, and hence find the A inverse. Okay, then solution. By the data, the examiner given you A, matrix A, square matrix A is given by examiner. A equal to 5 minus 2, 3, 1. And characteristic equation is given by the determinant of A minus lambda equal to 0. And if you use this formula, it is a lengthy. And this is a shortcut method, you remember. This characteristic equation is given by for the 2 by 2 matrix. This is the formula. Lambda square minus summation of D into lambda plus determinant of A equal to 0. Then lambda square minus lambda summation of D means summation of diagonal elements. 5 plus 1 plus and determinant of A 5 into 1 5 minus into minus plus and 3 into 2 6. 5 plus 6 equal to 0. And you are getting lambda square minus 6 lambda plus L1 equal to 0. This is a characteristic equation. Then next, the second point, he has asked you find the characteristic roots. Then characteristic equation is lambda square minus 6 lambda plus L1 equal to 0. You compare this with the binomial equation. A lambda square plus B lambda plus C equal to 0. Therefore, lambda equal to minus B plus or minus root of B square minus 4AC upon 2A. You simply write the formula. And I will tell you how to get the answer in calculator. And press the mode button, the on the calculator, mode button, and fifth button. And this is a quadratic equation, then third button. Then such a dialog box is opened there. And cursor is here. Okay. Now, look here, cursor is here. Then you have to enter the coefficient of lambda square, 1. 1 equal to button. And now the cursor comes here. Then the coefficient of lambda minus 6 and equal to button. Then cursor comes here. Then constant term C. Then L1 equal to button. And again press the equal to button. You are getting 3 plus or minus 1.414i. Therefore, lambda 1 equal to 3 plus 1.414i. Lambda 2 equal to 3.1.414i. These are the two values of lambda. Means characteristic roots there. Okay. Now, next, the verification of solution. Whether those roots are correct or not, you have to verify. This is for your in the examination, not necessary. For your the satisfaction, you have to do. You remember summation of lambda equal to 6. That is 6 is coefficient of lambda. Look here. This 6 is coefficient of lambda. Okay. The summation of lambda equal to 6. And the product of lambda 1 into lambda 2 equal to determinant value you have to get. That is L1. Then look here. Lambda 1 summation of lambda means lambda 1 plus lambda 2 3 plus 1.414i plus 3 minus 3 minus 1.414i. Then minus plus getting cancelled 6. Look here, 6 you got. Similarly, you take then lambda 1 into lambda 2. 3 plus 1.414i, close the bracket. Next bracket 3 minus 1.414i. Then equal to, you are getting 10.99. How to do this? Then press the on the calculator, press the mode button, then number 2 button. This is you brought the calculator to complex mode. Then you bring 3 plus 1.414i close the bracket, in another bracket 3.3 minus 1.414i, and close the bracket, equal to button you are getting in calculator, and this is rounded to the L1. Okay, you got it. See the verification of now Cayley-Hamilton theorem. How to do it? What is Cayley-Hamilton theorem? The every square matrix satisfies its characteristic equation. That is, put lambda equal to A, multiply the constant by I in the characteristic equation 1. That is lambda square minus 6 lambda plus L1 equal to 0. In this characteristic equation, replace lambda by A and multiply this constant by I. Then L1 I it is. Look here. Minus A square minus 6A plus L1 I equal to 0. This is equation number 2. Then A square. Look here. What is this? LHS. LHS equal to RHS 0 you should get. Take LHS. A square minus 6A plus L1I. And look here. A square means A into A. 5 minus 2, 3, 1. And in another 5 minus 2, 3, 1. And minus 6 into A. 5 minus 2, 3, 1. Plus L1I. 1, 0, 0, 1. The I is unity matrix. Diagonal elements are 0. The diagonal elements are 1 and other elements are 0. That is the unit matrix I. Then look here. How to do this in calculator? Look here. You press the on the calculator mode button. Then 6. You press the 6 one. Then look here. Again shift. Then AC. Look here. Say on the calculator mode button and 6. Okay. Then number 1. You press the number 1. It asks the dimension of A. A is 2 by 2. That is 5. Then look here. Such a box is opened there. Such a box is opened there. 2 by 2 matrix. Then look here. 5 equal to button, minus 2 equal to button, 3 equal to button, 1 equal to button. And AC button. Then the AC button. Then shift and fourth button. Then again third button. That is in the display of calculator, mat A has come. Mat A. And you press the X square button, it becomes X square. And you are getting this value. 19 minus 12, 18 minus 5. Plus, look here. Again, see here, minus 6. The AC button, minus 6. And into, again shift 1. Again shift and 4. Shift and 4. Minus 6 into shift and fourth one. What you want? The matrix A 3 and equal to button. Then you are getting, because I have sent that minus in inside for our convenience. Then minus 30, 12, minus 18, 6. Plus, this is very simple. L1, here, look here, L1 into 1, L1 into 0, 0, L1 into 0, 0, and again L1. And if we add all the first elements, and the 0, 0, 0 you are getting. This is equal to 0 RHS. Hence, the Cayley-Hamilton theorem is verified. Okay. Now, next, finding the A inverse. My dear students, multiply the equation 2 by A inverse. Look here. Equation 2. A square minus 6A plus L1y. Multiply this equation by A inverse. You are getting inverse. Look here, multiply the equation 2 by A inverse and use these quantities. A into A inverse equal to I into A equal to A, I into A inverse equal to A. These are identity multiplication of with the identity matrix. Then A square, A inverse minus 6A, A inverse plus L1I, A inverse 0, A inverse. Then next, look here. A square can be as A into A inverse minus A into A inverse is, look here, already I have given you I. Then L1 I into A inverse. Look here, I into A inverse is A inverse. L1 A inverse equal to 0. Then A into A inverse is I. A into I is A. Then A minus 6I plus L1 A inverse equal to 0. Then we are interested in finding the value of A inverse and keep this term this side LHS and send this to the RHS. If you send it to the RHS, it becomes minus 6I becomes plus 6I minus plus A becomes minus A. Then 6I means 6006. And look here, minus I make it a plus and take this minus inside the A. Minus 5, 2, minus 3, 1. And simply add with adding becomes simple, easy it is. Then 6 minus 5, 1, 0. Look here, 6 minus 5, 1 and 0 plus 2, 2. And 0 minus 3, 6 minus 1, 5. Then look here, I am interested in 5. This is equal to L1 A inverse, but A inverse I want. Transfer this L1 other side. A inverse equal to the 1, 2, minus 3, 5 divided by L1. This is the inverse, A inverse I am getting. Then verification of this result with our standard result. A inverse is given by adjoint A divided by determinant of A. Look here, adjoint A means, see here, A, the interchange the principal diagonal elements, interchange the principal diagonal elements of A and change the sign of secondary diagonals. That is equal to adjoint. Then look here, this 5 was here in A and 5 comes here. Here 1, it goes there. Interchange the principal diagonal elements and change the sign of secondary diagonal elements. Minus 2 was there, plus 2. And 3 was there, minus 3. Divided by the determinant is L1. Already you know. See here, this result is same. In this way, you have to do these problems. Wish you good luck. Have a nice time. Good day, my dear students.